Welcome to another daily algebra problem set. So we're going to start with question 1, solve x squared plus 2x minus 35 for x. So for this one, we can use the quadratic formula, or we can just factor. Since these are pretty easy numbers to work with, we're just going to factor. So we'll rewrite our expression, x squared plus 2x minus 35. And now what we're really looking for are two numbers that add to 2 and multiply to negative 35. So we can break this up into different factors of 35. We can say, okay, we've got 7 and negative 5, right? We've got negative 7 and 5. We've got 35 and negative 1, negative 35 and 1. And, there might be a few others, maybe not, but we can start with these. So let's just start with this one. These two numbers obviously do not add up to positive 2. Negative 35 plus 1 is negative 34. So we can scratch that out. That's not going to work. 35 and negative 1, they multiply to negative 35, but they add to 34. So we can scratch that out. Negative 7 and positive 5. We're getting a little closer with this. Negative 7 times 5 equals negative 35, but negative 7 plus 5 equals negative 2. We need a positive 2. Now on to the last one. 7 minus 5 is 2, so we can put this into our factor. We can rewrite this as 2 plus 7 times x minus 5. And we'll set this equal to 0 because we're going to solve for x here. Now we can take these factors and set them equal to 0. X plus 7 equals 0, and x minus 5 equals 0. And so our values of x that satisfy this equation should be x equals negative 7 and x equals 5. Now if we want, we can plug these into this expression and find whether they simplify down to 0. But we're not going to bother doing that. You can do that if you so choose. This is how you would solve for x in this problem. Moving on to question 2, simplify the expression a squared times b to the negative third times c to the fourth all over c to the negative first times a squared times b to the fifth. Okay, so the first thing to do, besides rewriting it, is we're going to look to get rid of these negative terms. And we're going to do that by basically flipping them from the numerator to the denominator or the denominator to the numerator, depending on where they are. So, for example, here we have a negative 1. So we're going to rewrite this as, rewrite this as a squared times c to the 1, right? We're just going to flip it into the numerator. We have a b to the negative third, so we're going to flip that into the denominator. We'll rewrite this as, we have an a squared here, so we'll write that first, and then b cubed, this term just drops down to the denominator. We have a c to the fourth here, and a b to the fifth here. Okay, now remember that if we have some sort of term x squared over x squared, this is just equal to 1, right? Because something divided by itself is just 1. So these terms are just going to cancel. Now we'll just have c to the first times c to the fourth over b to the third times b to the fifth. Okay? And now remember your exponent rules. If you're multiplying the same base with an exponent, you just add the exponents. So c to the first times c to the fourth is just c to the fifth, over b cubed times b to the fifth is just b to the eighth. And this is our simplified expression. Moving on to our last problem, problem 3, we're going to calculate a bunch of factorials. So find 5 factorial, find 3 factorial times 2 factorial, and find 4 factorial times 6 factorial all over 2 factorial times 3 factorial. Starting with 5 factorial, we have to remember what a factorial means. This just means we're going to multiply every term up to and including this value. So we can rewrite this as 5 times 4 times 3 times 2 times 1. We can simplify terms here, so let's see, 3 times 2 is 6, so we can rewrite 5 times 4 times 6. 5 times 4 is 20, so that's 20 times 6, which is just 120. Okay, now moving on to the second one, 3 factorial times 2 factorial. This is 3 times 2 times 1 times 2 times 1, right? We can rewrite this as 3 times 2 times 1 is 6, times 2 times 1 is 2, which is 12. Okay, so that's the second one. Now moving on to the last problem here, we have 4 factorial times 6 factorial, all over 2 factorial times 3 factorial. We will expand this out, and we're going to drop the 1s here because they don't affect the final answer. So 4 times 3 times 2 times 6 times 5 times 4 times 3 times 2 over 2 times 3 times 2. Since we're dividing, we can cancel out certain terms here. So 2, 3, and 2, which leaves us with 4 times 3 times 6 times 5 times 4. And when we multiply all this out, we will find that this equals 1,440.